Alright, so here we go, the last step. We know how to set up, we know how to create our files. Now we need to know how to read them in. Now we got to be careful. There's more potential for problems and crashes in reading than there is writing, because if you're trying to read data that doesn't actually exist there, you could end up with a problem. So you got to be careful about that. So you may want a little bit more than what I have shown here inside of the try block. That's up to you to decide how confident you are in the structure of your file. So basically, the first rule of reading is you got to make sure that your file is structured the way you expect it to be structured. In my case, I have 2 lines of really nothing and then 4 lines of actual data. So I got to kind of chew up those first 2 lines before I can get to the real data. Because with everything, when you read in a file, it reads from top to bottom. Okay? So how do we actually do this? Good thing is it works almost identically to the way that we do our console input. So we have our scanner. So in console we usually call this like input or something like that. So in this case we're going to call it reader, since we called the other one writer. And inside my try block I'm going to try and create this scanner. Now instead of saying input equals new scanner system.in, we're not getting it from the system now. Now we're getting it from a file. So we can say reader, which is our scanner, is equal to a new scanner using a new file. This file is a fancy object that really just kind of sets up the file and opens it for reading the data in. And we got to specify the file name. You notice the only parameter this time is file name. There's no append or anything like that because we're not changing the file. We're just reading in what's actually there. And similarly speaking, we still have a catch. You notice this time it's just exception E. The reason why it's exception here, E, whereas this one is IO exception in the right, is exception is a general term for exception, which means it'll catch all different types of exceptions, whereas IO exception will only catch those specific types of exceptions. Now, since there's so many potential problems that can arise from reading a file, I'm just going to use the general exception object, and that way I can kind of have that super safety net and make sure nothing else breaks. So if it does error on setting up the scanner, it's going to print the stack trace just as before, and it's going to return false saying nope, couldn't read it, failed. Alright, so let's assume that you got the scanner set up. Next step, we just have to read in the file. So we have to chew through it from top to bottom. We got to read in one whole line at a time. There are some other ways of doing that, but I'm not going to get into that at this point. I'm going to try and be consistent with the same way that we read in from the console. That way you're used to it and there's no big changes or anything like that. So, first thing I want to do is I want to read in those 2 lines that we saw at the top there. What I'm going to do is, if you recall from the previous video, I had that output string up here. All I'm going to do is read in those 2 lines and put them into that variable. I'm just going to concatenate them one on top of the other, or one in front of the other. So output is equal to the current value of output, which is nothing, and I'm going to concatenate reader.nextLine. So it's going to read in the whole line, and it's going to put it at the end of output. So nothing plus this is line 1 is equal to this is line 1. And then I'm going to read the next line. Output is equal to the current value of output, which is this is line 1, and concatenate that with the next line, which is this is line 2. So now we have this is line 1, this is line 2. No spaces, no punctuation in between, just stitched together at the end. So that will give us the output that we see down here. This is that one variable being outputted all at one time. That's why it's not very pretty. That's okay. If we want to make it pretty, we would just do different concatenation here. So now the tricky part, the part that actually matters. This can be the most complex part when it comes into reading files. So what we're going to do is we're going to break this data up. We're going to read it in one line at a time. And now the problem is that because our line has more than one piece of information, we need to know how to break it apart at that whatever's separating all of our data. We call that thing that separates each piece of data a delimiter. In this case, our delimiter is a comma. Looking at here, there's a comma separating our two pieces of information. So what we're going to do is we're going to read in one line of data at a time, and that's going to be stored in this data variable. Okay, and then what we're going to do is we're going to take that data variable and we're going to cut it up. We're going to splice it up at the comma, and the first piece of information, which is the name, is we're going to store that into the names array. The second piece of information, the right side of the comma, is going to be the phone number. We're going to store that into the phone numbers array. This integer data lines, all that is doing is keeping track of which line number we're actually on in terms of reading these names and phone numbers. So obviously that starts at 0 because we haven't actually read in any names or phone numbers yet. Alright, so let's go through this. What I want to point out is I'm using a while loop here. And I'm using a special command here that says while reader dot has next line. So let's assume that I have this phone book of names and phone numbers, but I don't know how many names and phone numbers I have. Well, that's a problem, because if I start to add in like 6 or 7 more, I need to be able to read in that data as well. But if I don't know how many, how am I going to know when to stop reading? Because if I try and read more than the file has, it's going to crash. It's going to say, sorry, you read past the boundary. Same thing as if you go past the end of an array boundary. So what we're going to do is we're going to use a while loop that says, hey, as long as there's a next line, read in some more data. So once we've decided that there is more data to read, we're going to say data is equal to reader.nextLine. The same thing that we did up here. So we've read in one line. So when we read in that first line, it's going to be Jane, 555-1234. Sure, no problem. Now what we want to do is we want to cut it up. We got to find where that comma is. What index of that big string, Jane, 555-1234, is the comma located at? So we're going to use the index of command. So if you remember back to our string manipulation lessons, index of will return the index where the first comma occurs inside of the string. So comma index is equal to data.index of. So this tells us where our kind of midpoint is. Midpoint of the data, not midpoint of the string. So now all I have to do is grab everything up to that comma, and that's my name. And then everything after the comma is my phone number. So that's what I'm using here with the substring command. Start at 0 and go up to the comma. Store that value inside of the names array. Which index of the names array? Well, whichever line number we're currently on. Then everything after the comma will be our phone number. Now we're using the special version of substring where we only have to specify a start index, and then it'll read all the way to the end of the string, which is great. It makes our lives a lot easier. We don't have to detect how much of the string is still left. And then that value is going to be stored directly into the phone numbers array. So 555-1234. And at the end of that full line, we want to increase our data lines because we just successfully read a whole line. And it's going to come back up and do the whole while loop again. And it's going to continue this process of read in a full line, cut it up at the comma, grab everything before the comma for a name, grab everything after the comma for the phone number. That is going to keep repeating itself until all of the data is read in. When we're finished that, just like we did with the writer, we have to close our file saying, hey, we're all done with this, something else can now use it. And since we were successful, let's return true. Great. So we've read in our data and we've stored it in our arrays and our output variable. So what do we do with it? Anything we want. It depends on what your program is. Maybe I just read in a high scoreboard. Maybe I just read in a contact list that the user can then later search through and find certain names or whatever. It's up to you as the programmer. It depends on what your program needs to do. So up in here in the main, after I have wrote and read all the files, now we'll get into where and when you would do this in your program in a second. For my purposes, just to show you that we actually read in everything, I'm just displaying all that data. So I displayed that output string, and then I went through a for loop that went through the two arrays, the two parallel arrays, and displayed their data on the screen with a little arrow in between to show that Jane's phone number is 555-1234. You notice that there's no comma because it's not just one big string. These are two separate pieces of data. Now I mentioned a second ago that I talk about where you should be reading and writing files. Well, that depends on the purpose of the reading and writing. So for example, if you were making Microsoft Office and you wanted to save the person's file, that happens at 2 points. It happens when the user manually chooses the save button, in which case the file is then stored on the computer as normal. It will also happen during the autosave. Every system by default saves every 5 minutes. It's going to save your file just in case the program crashes, the computer crashes, so you don't lose a huge amount of data. That's great. So that saving happens while you're working on a file. But what about the loading? It doesn't load every Word file on your computer immediately when Word opens. You have to go through the process and manually choose to load. So that's a manual trigger. However, if you're building another program, let's say for example you're building a program with a high scoreboard or something like that. So basically what you're going to want to do is at the very beginning of the program, you want to read in all the old high scores. Then you can store them. That's great. The user plays their game, and if they beat a high score, maybe it overwrites that value in the array, but then you need to save it again. That way if the program crashes, you still have a persistent version of that high score. So that's an automatic thing. The user doesn't have to load the high scores manually. The user doesn't manually save the high scores. That should happen automatically. The load happens whenever the program opens, and the save happens whenever a new score is entered. Whenever a new score is achieved, a new higher score I should say. So it all depends on your program and how you're going to use it. Now, where does Java save these files? Well, by default, you'll notice that I'm just specifying a file name. You can customize this, but basically what's going to happen is by default it is stored in the main root of your project folder. So my project is called file.io, so it's stored right there. There's the testfile.txt. Don't forget your .txt or you won't be able to look at it in Word. If you don't put it there, that doesn't mean your program won't be able to load it. It'll still load it just fine. But you won't be able to manually look at it to make sure everything works and is hunky-dory. So that is file.io. We talked about how to set up a file, we talked about how to do try catches, we talked about how to write, and now we've talked about how to read. So you should be able to save your programs or do whatever you want at this point. Maybe save a level that the user created, load levels that you created, all sorts of stuff. Thanks for listening.